Following on from the previous video, I still need to explain this thing here. Well, this thing here is connected to your unit vector, so you could work in any direction. You can work out the gradient no matter which direction you move in. Let's just say, for instance, you want to move 4 across in the x direction. By the way, it should be a unit vector, but I just want to explain this. So let me use a vector that's not a unit vector. So 4 across, and then 3 up in the y direction, 3 up in the y direction. So we are looking at this vector here, 3 up. So this vector here, we are looking at this vector. We are looking at this vector here. Okay, so let me just redraw this part. So redrawing this part in 2D will look like this. We've moved 4 across and then 3 up. So you can express a vector in parametric form. So we've moved 4 across and then 3 up. So when you see this thing here, in your mind, picture this. Because all it's doing is that it's telling you to move 4 across and then move 3 up, and it doesn't matter which point where you start at in the x and y location. The x and y location, it doesn't matter where you start. So this x and y, it doesn't really matter. This thing here, so this thing here is really a vector, and the reason why you have this s here is, imagine s as being like time. So time ticks away. 1 second, 2, 3, 4, 5, and so on. Let's say 3 seconds later, 1, 2, 3. That means, looking at this is our vector 3. This is our vector 1, and then 2, and then 3. So this vector tells you the direction in which you move in. But the thing is, we don't want to work. We want to work with a unit vector rather than a vector of, let's say, magnitude 5. Let's say magnitude 5. 1, 2, 3, 4, 5. We don't want to work with a magnitude of 5, because if you go back to here, I'm trying to explain why it needs to be a unit vector. So remember our vertical sheet of paper in the direction of our vector. So this is our vertical sheet of paper. Bear with me. This is our vertical sheet of paper, and this sheet of paper is really a flat 2D sheet of paper. So we can translate it to this. Well, the reason why we don't want to work with a magnitude of 5 is because of this. Remember, s is like time. S is like time, is ticking away. 0, 1, 2, 3, 4. If time ticks away by 1 second, say 1 second, then this after 1 second, it would have moved 5 units in our direction. So what that means is, after 1 second, you would have moved 5 across here. You would have moved 5 across, which is complicated, because you want a scenario where one second correlates to a distance of 1. 2 seconds, 1, 2. You want it to correlate with 1, 2 in the s direction. So if you use a vector of if you use a unit vector 1, and then if you use a unit vector, then 2 seconds over here would mean a distance of 2 in the direction that you're talking about. 1, 2. If you jump by 3 seconds, 1, 2, 3, then you would have jumped a distance of 3 in the direction in the u direction. So this is why we need to work in a unit vector rather than a magnitude of 5. So if you get given this, you can turn it into a unit vector by looking at the unit, looking at the vector, and then divide it by its magnitude. So in our case here, we can divide it by 5. So we can use this 4 over 5 3 over 5. Now this is a unit vector now, and then when time ticks away, let's say 3, 1, 2, 3, then on our diagram you would actually move 3 across. You would actually move 3 across, 1, 2, 3. So it's better to use a unit vector. And I've still got to explain why you get this and multiply with this, and why you would get this, multiply with this. This will be in the next video. Okay.